One of the habits from Stephen Covey's 7 Habits of Highly Effective People is to begin with the end in mind. And so it is with this video. We'll be introducing the end of analysis phase, which is the system proposal. It's important as we begin analysis phase to have our target or our goal in mind, which is to prepare, in many cases, a formal document proposing a system and its requirements. And we're going to explore every dimension of this document as a part of this module. After this video, you'll be able to identify the artifacts from plan phase that we revise during analysis phase. You'll also be able to describe the new artifacts that we create during analysis phase. And by the end of this video, you'll be able to list at least one diagram type that we use to understand the current business process. Taking a look at where we've come and where we're going, in the first module, we explored plan phase, and we briefly talked about things like creating a project plan and managing the triple constraint. All of this then feeds into analysis phase. At the end of analysis phase, we'll have a system proposal. This system proposal is a detailed list of requirements as well as diagrams that describe the system being proposed. The system proposal then serves as the input into design phase. We will be spending most of the time in this course in analysis phase, since the role of the BA or the business analyst is the greatest during analysis phase. We will wrap up the course by talking about design phase and the role of the BA, continuing role of the BA in design phase. But for these modules, we're going to focus mostly on the analysis phase, the types of activities and the types of documentation and artifacts that the business analyst creates during these phases. During analyze phase, we clarify requirements, we understand the current process, which is often the first step and often skipped when doing business analysis, and then we develop changes to the current business process. All of these result in a system proposal that is then used as input into the design phase. A system proposal is the end of analysis phase. All of the deliverables are combined, from analysis phase are combined into a system proposal, which is then typically presented to management. Different organizations have different names. Many of them might not use system proposal. They might use something else. In principle, though, the documentation is largely the same. It's a packet of requirements, as well as supplementary diagrams and other documentation that describe the system to be implemented. And typically, organizations will make a decision at that point as to whether they move forward or decide to put it on the shelf. This is a list of potential deliverables, some of which we created during plan phase, and others of which are new to analysis phase. The system request, the work plan, and the feasibility analysis are all things that we talked about in the earlier module. However, they're not completely done after that phase. As part of analysis phase, we often kind of dust them off, revisit them, and iterate them. This means that we add additional detail, or perhaps new information has become available and we need to revise those artifacts for whatever reason. In analysis phase, we then move on to creating new artifacts and deliverables. These include requirements, which is where we'll spend a lot of our time, writing good, unambiguous requirements for the system. A tool that helps us elicit requirements is use cases, and we'll spend time learning how to write a use case and draw a use case diagram, which tells us how use cases relate to one another. Your process model is, we will use data flow diagrams to describe the process model, and we'll explore in depth how to create those diagrams and how to balance those diagrams. And finally, we'll use a technique called entity relationship diagrams to describe the data model of the system. This usually describes what types of data the system stores and how that data relates to the other pieces of data in the system. What is missing from the list that you see here is kind of the human element of what needs to go on during analysis phase. We talked about the concept of organizational readiness in the earlier module. During analysis phase, you need to continue your organizational readiness activities, and we will have suggestions for you as to what those activities could be. You'll also need to think about project teams, who will be doing the work, and not just a list of tasks that need to be accomplished. So there's a lot missing here, but this will at least get you started with the important artifacts that we'll be creating in analysis phase, and this is where we'll be spending most of our time. We begin analysis phase by trying to understand the system as it currently works, or the process, I should say, as it currently works. This is often the most neglected step in analysis phase. It's very tempting to sit down and dream up how you want things to work without regard to how things currently work. And oftentimes we find that we actually don't fully understand how things currently work. I'll give you an example. When I worked for 3M, one of the things that our customers would tell us that we would do is we would often come in and ask a lot of questions about how their current process works, and they would give us feedback that as part of that process they came to a greater understanding of their own internal processes. And oftentimes we'd talk to, say, 5 people, and the 5 of them would have a different definition of what occurs during the same business process. All of that is to illustrate that understanding the current process should be an important step in your analysis phase. How do we do that? Well, one of the ways that we do that, not the only way, would be to use something like a swim lane diagram or a flow chart to document the current process. In the best possible case, a flow chart of the current process might already exist. However, you have to take care because this flow chart might not be up to date. And so the process of updating the flow chart can often lead to new insights about the process. So we use a swim lane diagram or a flow chart to document the current process. That's just one idea for how to start analysis phase. As we move ahead in this lesson, we're going to dig into how we create requirements and the different dimensions and aspects of writing requirements. And then after that, we'll move on to other tools such as use cases, prototypes, and so on that help us further refine what the system should be. We probably all heard the story of the product that didn't quite meet the customer's expectations. In our new language, this would mean that the product didn't meet the customer's requirements. We're going to talk today about writing good requirements so that you can develop a software product that ultimately meets your customers' or your business's needs. After this video, you'll be able to describe the purpose of writing requirements, as well as list the qualities of a well-formed requirement. Future videos will go into greater depth on the language that we use to write requirements so that they are unambiguous and easy to implement. In our overall process, we've been trying to understand the as-is system. With this video, we're starting our focus on requirements, which is one of the primary roles of the business analyst. Whether you're writing traditional requirements, like you might do in a mature software organization, or whether you're writing agile user stories, like you might do at a smaller IT organization or a startup company, the principles of writing clear, unambiguous requirements are the same. So most of what we talk about can apply equally to traditional requirements versus agile user stories. Future videos will go into the rest of the process, such as resolving priority and developing test cases. But let's start our discussion about requirements. The purpose of writing requirements is actually communication, whether it's to gain approval from top down, so this might be users or stakeholders or upper management, or to tell developers down the line what to build, or to tell a committee what type of software they should select if they're buying commercial off-the-shelf software. We also write requirements so that testers know what the software should do, as well as letting the marketers know what the software will do so that they can prepare marketing material. All in all, the overall purpose of writing the requirements is communication. Perhaps the number one rule, whether you're writing a requirement or an agile user story, is that the requirements should not state how the system will meet the requirement, only what the system should do. Requirements are so important that they're actually covered by the International Standards Organization, otherwise known as ISO, in a document you see here, 29148:2011. This document represents many years of thinking on writing the best requirements possible. And so I'm going to use this document to guide us in our discussion about what makes a good requirement. According to this document, good requirements can be verified. That means that once the system is complete, we have a way of knowing whether or not the system meets the requirement. In my head, I have the story of a requirement in a project that I worked on where the requirement stated that the software should have a beautiful user interface. When the tester came back to me and said, I have no way to verify that this interface is beautiful, he ended up printing out a copy of the user interface, posting it on the outside of his cubicle, and asking people to vote on whether or not it was beautiful. The requirement has to be met or possessed by a system. or to solve a stakeholder problem or to achieve an objective. So in other words, it can't be a quality of the user or the business environment. Good requirements are also measurable. You may have heard the acronym SMART in your performance goals: specific, measurable, achievable, relevant, and time-bound. We can often use this acronym when writing good requirements as a way to test whether or not the requirement is good as well. Good requirements define the performance of the system, and again, not the performance of the user, operator, or other stakeholder. So it tells what the system will be able to do or what the system allows, and not necessarily the specific capabilities of a user. Other important aspects: we should uniquely identify our requirements. We usually achieve this by giving each requirement a number. In some organizations, the numbering system can be quite sophisticated. In other organizations, it might be something as simple as an Excel spreadsheet that starts with 1 and numbers 2, 3, 4, and so on. We should give our requirements a priority. It's inevitable that projects will come under time and budget constraints. When these time and budget constraints come down, one way to decide what we can do with the time or the money we have left is simply to organize your requirements by priority. It's most useful if this is done in advance when you're writing the requirements, and not as a fire drill when the budget constraints or the time constraints come in. We should also work to identify dependencies. Some requirements are only relevant if a previous requirement is implemented, and so having a column or a field in your requirements document to indicate dependencies is a good practice. We'll talk a little bit later in the course about the concept of traceability, but good requirements should be traceable to the source. So in other words, when looking at a requirement in a requirements document or a requirements management system or an Agile user story database, we should know where that came from. We'll discuss in future modules techniques for gathering requirements in user stories. These include things like interviews and document analysis. This is the point where we would identify where this particular requirement came from. It might be helpful sometimes to include some rationale about why the requirement is part of the system. This way, when new management comes in or new team members come in, they don't always question the source of the requirement or whether we should be doing what we're doing. It's often helpful to indicate the difficulty. So, and this could be just a high, medium, low in terms of the amount of effort required to implement a requirement. In a lot of cases, easy requirements can be done in a matter of hours or implemented in a matter of hours and kind of moved off the list, while more difficult requirements can take weeks or even months. And finally, we should categorize the requirements. Future video will talk about the difference between functional and non-functional requirements. Many of us may have been on a project that had bad requirements, and it's often fun to sit around and look at a requirements document and critique it. It's always much easier to be in the position of critic than it is to be in the position of actually having to create and write the requirements. But we won't always be able to simply be critical. Instead, many of us will be in the position of actually having to write a requirement or an Agile user story. And so it's helpful to know how to construct a good one and not necessarily just how to critique requirements that might be poorly written. In this video, we're going to talk about individual requirements and how to construct a good, clear, and unambiguous requirement. At the end of this video, you'll be able to list the desirable qualities of good requirements, and you'll be able to define those qualities. Let's remind ourselves where we are in our process. The primary role of the BA is during the analysis phase to prepare documentation that helps developers or a selection committee know what system to implement. One of the primary roles during analysis phase is writing requirements. Other roles of the BA include preparing diagrams and other documentation that will be covered in future modules. But for now, let's start our walk through a list of qualities that are desirable in good requirements. First, requirements should be necessary, and this may seem obvious, but I've seen plenty of requirements documents that have essentially optional functionality in there. The requirement is currently applicable and has not been made obsolete by the passage of time, and this is difficult with traditional projects, although slightly easier when keeping databases of Agile user stories up to date. Requirements with planned expiration dates or applicability dates should be clearly identified. A classic example of this is the Y2K problem. At the end of the 1990s, many systems needed to be updated in order to support a 4-digit year in the date. It's pretty clear that if these requirements weren't implemented by the end of 1999, there would be a problem with the system. Therefore, these requirements should have a clear date of applicability on them. Requirements should be free of implementation, and this is probably one of the biggest traps that we fall into when we're writing requirements. We specify how the system should do a particular function rather than what it should be doing. I know I've been in the meeting where I catch myself solutioning, which is essentially dreaming up solutions to a problem and not thinking instead about what the system should do. There will be time later to design how the system should meet that particular requirement. Requirements should be unambiguous. Now, this might seem, again, straightforward and obvious, but the requirement should be stated in such a way that it can be interpreted in only one way. One easy suggestion that I implemented several times in my career is to give the requirement to someone who's unfamiliar with the system or project. This could be an administrator or even an upper-level manager who doesn't have a lot of contact with the project. Get their reaction. If they can understand the requirement, then that's a good indication that the requirement is unambiguous. If they have a lot of questions, on the other hand, those questions can help you refine the language to make it unambiguous. Requirements should be consistent. This means essentially that one requirement should not conflict with other requirements. On a small project, this is relatively easy to keep track of. However, on larger projects, this can quickly become a problem. Requirements management tools, which essentially are software that helps us manage our requirements, and there's a similar suites of software to help manage agile user stories, can help with this consistency problem. Eventually, a project grows beyond the capabilities of an Excel spreadsheet or a Word document, and we need to move into more sophisticated systems to help us keep our requirements consistent with each other. The requirement should be complete. This means that the requirement needs no further clarification than what is written. And again, the test I use is if someone were to find the requirement or the document lying on the floor in the hallway and pick it up, that they would be able to read and understand it without any additional context needed. Requirements should state one specific function with no use of conjunctions in the language. Or in this case, a requirement should not define multiple capabilities of the system. Now, this is important, number one, for clarity, but also later for traceability. If a requirement describes two or more different functions, it might be true that those functions were uncovered through two or more different sources, and we want to maintain traceability to the source. If you write a requirement that seems to specify multiple kind of functionalities of the system, then the solution is usually to break that up into two or more individual requirements and give each its own number. Requirements should be feasible. That means that the requirement is technically achievable and does not require major technology advances. I do have one interesting story about this. I remember I was at an organization and we were selecting a requirements management tool. One of the vendors of these tools came in to give us a demonstration, and part of their sales pitch is that the requirements tool is actually used to manage requirements for the U.S. Joint Strike Fighter program. One of the requirements, or a set of requirements in there, was that the fighter should be able to essentially go faster and turn quicker than any available fighter jet on the market. And so this was an example of something that may or may not have been technically achievable, but most requirements should be well within the realm of technical achievement. Requirements should be traceable. This is important enough that we'll spend a future video talking a little bit about traceability and the importance of this, as well as different types of traceability, forward traceability and backward traceability, and why we have the different types of traceability. Verifiability refers to our ability to essentially ensure or test the software package to make sure that it does the required function. There's a number of requirements that are not measurable or verifiable in this sense, and so we like to make sure that there is a way that we can test our requirement on the back end and make sure that we can verify that the system actually does meet that requirement. Those are some of the qualities of a good individual requirement. I'm going to end by showing you an example that comes from 30 key requirements for an enterprise resource planning system replacement. This is just a couple of the requirements, and I'll ask you to spend some time looking at these requirements and, based on what we just learned, see if you can identify what they did well as one thing that could potentially be improved. Future videos will dig into the kinds of language that you should use when writing requirements. In the previous lesson, we talked about the qualities of a good requirement. Now let's dig into the specifics of the language you should and should not use when writing your requirements. After this video, you'll be able to describe the basic language elements used to construct a good requirement. You'll also be able to list common pitfalls in writing requirements and how to avoid them. And we'll end by going over 3 sample syntaxes that you can use to write good requirements. And again, whether you're writing requirements or Agile user stories, I think you'll find the information here equally applicable. In the larger context of things, remember that we are in the analysis phase, and we're talking about writing requirements, which is one of the primary functions of a business analyst. Future lessons will go into things such as requirements gathering methods, diagrams, and other documentation that the business analyst prepares during analysis phase. Let's talk about requirements and the language you should use when writing requirements. Requirements that are mandatory and binding shall use shall. Most of your requirements will probably fit into this category. So examples are: the system shall provide a way for the user to create an invoice. That's a simple requirement that unambiguously states that this needs to be part of the system. Sometimes there is a preference or a goal or some desired functionality, but it's non-mandatory. In this case, you can use the word should in your requirement. Other things in your requirements document might be suggestions or allowances. In this case, you can use the word may. So the system may provide a means for the user to create an invoice if the functionality is not required. Non-requirements, such as descriptive text, use verbs such as are, is, and was. It is best to avoid using the term must, because this might lead to interpretation as a requirement. It's not that this language doesn't have a place in our requirements document, it's just that we want to avoid mistaking descriptive text for an actual requirement of the system. It's useful if we phrase our requirements in terms of what the system should do instead of negative requirements such as what the system should prohibit or what the system does not need to do. We should use active voice. Avoid using passive language such as shall be able to select. It's best to avoid superlatives because these aren't measurable. There's no way to know whether or not we have the best system or the best user interface. And then therefore it's not testable, so there's no way to verify that it would meet a requirement with that kind of language. Avoid subjective language such as user-friendly, easy to use, cost-effective. And I've already given an example of a requirement in my career where this happened. Finally, vague pronouns such as it, this, and that. Instead, replace the pronoun with the proper noun that it refers to. Ambiguous adverbs and adjectives, almost, always, significant, minimal. Again, these are not measurable, and we should avoid use of these in our requirements. Open-ended, non-verifiable terms, such as be able to provide support for, but not limited to, as a minimum, we should avoid these, as well as comparative phrases, such as better than or higher quality. Loopholes, such as if possible, because you can always just determine that it's not possible and not implement that requirement or as applicable. Finally, incomplete references, such as not specifying the reference with its date and version number, not specifying just the applicable parts of the reference to restrict verification work. There are often many versions of documents out there, and we need to be clear about what version of a particular document we're referring to. And finally, avoid negative statements, such as statements of system capability not to be provided. Those are things that you should avoid. Now let's look at what you should do. I'm going to give you 3 sample syntaxes that ISO recommends as part of their requirements documentation. The first example of how to construct a good requirement follows this pattern. It starts with some kind of condition, and then a subject takes an action on an object subject to some constraint. So for example, this would be in more of a real-time systems category. When signal X is received, the system shall set the signal X received bit within 2 seconds. Another variant of syntax would be starting with the condition. You can then move to an action or constraint and then a value. So at C state 1, the radar system shall detect targets at ranges out to 100 nautical miles. Finally, more of a business-oriented example, the subject action value. The invoice system shall display pending customer invoices in ascending order in which the invoices are to be paid. That concludes our look at writing good requirements. Next, we'll look at how to categorize requirements into functional and non-functional requirements and why that's important. When I was an intern at a local privately held company, I was asked to sit down and refine some requirements with one of the subject matter experts who happened to be a grain trader. As part of that refinement, I asked him what platforms the system needed to run on. He kind of gave me a blank stare in return, saying, "I really don't know. That's your job." I had actually confused a functional with a non-functional requirement. I was asking a business subject matter expert to essentially determine a non-functional requirement, which has implications on the design of the system. However, he's mostly responsible for functional requirements. So in this video, we'll go into the difference between functional and non-functional requirements and describe why it's important that we separate them. After this video, you'll be able to describe the purpose of separating requirements into functional versus non-functional categories, as well as list the characteristics of a functional or a non-functional requirement. Finally, and perhaps most importantly, you'll be able to categorize the requirements as functional or non-functional so that as you produce your documentation, you can be sure to put them in the right sections and deliver them to the right teams. As part of the analysis phase, we develop requirements, and that is probably the most intense part of analysis phase. It is a multi-step process that we've been exploring in depth. This particular video focuses on the part of the process where we separate requirements into functional versus non-functional requirements. Let's talk a little bit about what a functional requirement is versus a non-functional requirement. We use each type of requirement in a different way as we proceed with development. Functional requirements relate to the process that a system has to perform, so a specific calculation or a specific capability that it should have. Non-functional requirements, on the other hand, relate to constraints of the system. The example I gave at the beginning of the video, such as what platforms the system has to run on, is one common example. Other common examples are the languages the system needs to support, or any performance requirements such as the number of transactions or the number of users. These all fall into the non-functional requirements category. Functional requirements describe capabilities or functions that the system must perform. Here are some textbook examples of functional requirements, such as the system will allow managers to view the current new vehicle inventory, or the system will enable a salesperson to create a customer offer. These refer to specific functions that the system must perform. Functional requirements are different than non-functional requirements, which describe constraints of the system, such as what platforms the system must operate on, or specific timeframes or performance requirements, such as the number of users that it must support. Another common example that I discussed earlier was the languages that a system should support. And you can even see here some cultural or political implications, such as maybe we have a contract in place to only purchase hardware from a specific provider. Separating these is important because the non-functional requirements are essentially inputs into the design phase. They're forwarded to the developers who develop the system, or the team of people who might be making a build versus buy decision, so that they can make sure that the system meets the appropriate constraints. Functional requirements, on the other hand, are usually discussed with subject matter experts, so people who perform the tasks or functions every day to make sure that the functional requirements are correct. From here we'll be talking about, we've talked a lot about what requirements are, how to write them, and what the best practices are. From here we'll be talking about essentially how we go about gathering those requirements. There are lots of methods. At the beginning of this video, I described one popular method, which is the interview. Sit down with the subject matter and interview them. We'll also talk about other methods that you can use to develop and gather your requirements. We've learned about the qualities of writing good requirements, but we haven't talked a lot about where the information comes from that drives the requirements. In this video, we'll talk about requirements gathering methods. We'll talk about 4 popular methods for gathering requirements, though these are not the only methods, of course. After this video, you'll be able to list the primary requirements gathering methods, as well as construct a well-defined business problem. And finally, we'll have some suggested questions for a user requirements interview. Just a reminder that we're in the analysis phase of our systems development lifecycle and talking about writing requirements, which is one of the primary roles of the business analyst during this the systems development lifecycle. Whether you're writing traditional requirements or whether you're writing agile user stories, the advice and the techniques given here is equally applicable. Let's talk about 4 requirements gathering methods. We'll spend the most time talking about interviews because they are the most common way to get requirements. Later in the course, we'll talk about prototypes, and we'll cover this in more detail. Later in this video, we'll talk about document analysis briefly, and you were assigned to watch a video on ethnography and its role. Let's start by talking about interviews. Interviews should gather information about the interview subject. We often forget to ask these questions. Who are you? What do you do? Where do you fit in the organization chart? I've even asked people to show me an org chart and where they fit into it. This helps me better understand their role. Interviews should clearly identify the business problem. I'll give you a couple of examples in just a little bit. We should clarify the user environment and test potential solutions. Now, this is a tricky line because we just talked about the fact that requirements should describe the what and not the how. However, discussing potential solutions without deciding on the ultimate solution is a good way to see if you're on the right track. And finally, we should endeavor to identify non-functional requirements. Let's talk about each one of these. First, it's important to remember to ask about the interviewee. We might know their name, of course, or we might even work with them on a regular basis. But sometimes it can be level setting to ask them about their title, their role in the organization, or even, like I said, to ask them to show you an organizational chart and where they fit in. You might also inquire about barriers or issues that they have in performing their job responsibilities. Not only does this lead to additional requirements, but it can help gain the trust of the interviewee as well. Identifying the business problem is critical and often one of the most often underlooked aspects of conducting interviews and developing systems in general. There's a quote that says, "A problem well defined is half solved." The point of this, I would always tell my teams, is to spend more time than you think you should on defining the business problem. Let's look at a couple of examples. One example of a business problem might be, we don't have a system to take orders online. A second example that's similar might be, we can't take orders at the rate that customers are placing them. The first one actually is not an example of a business problem. The fact that you don't have a system is not a business problem. A system is a potential solution. The second one of these is better formulated as a business problem. We can't take orders at the rate customers are placing them. It's important to spend a lot of time, and I've even done full workshops with my teams sometimes, on how to define a business problem properly. This is, in many ways, a separate discipline, and I encourage you to do a little bit of research into this. Follow-up, such as what else is a problem, can always dig one level deeper. Many times the problems you identify in the interview can't be readily addressed by the project at hand, but it's good to identify and note these so that additional projects might be started later on and prioritized. It's important to talk about the user environment, such as who will use the system, what the user's level of training and education is. For example, are they kind of sophisticated and savvy computer users, or might using a computer be intimidating to them? What platforms the users use today. The introduction of the iPhone, for example, has changed the way that we interact with systems. People almost expect them to be touch systems these days. Also, we might uncover expectations for time on task, as well as what the expectations are for training. Some systems are designed as expert user systems, where users using them will be heavily trained. Other systems might be designed for ease of learning, such that an untrained person could sit down and figure out how to use the system in a short amount of time. Proposing potential solutions is an important, but also somewhat tricky proposition for the interview. On the one hand, you don't want to get too far into solutioning, too early in the process. On the other hand, proposing potential solutions, engaging users' reaction to them, might be an important source of additional requirements. It's important that you avoid deciding on the one solution or making promises about what the system will or will not do during a requirements gathering interview. However, It can be useful sometimes to speculate. If we had a system that did this, would it meet your needs? You can summarize the problem and share ideas with the user about potential solutions, emphasizing that the final solution is yet to come. We also want to identify any non-functional requirements during the interview. This might be requirements around availability of the system, performance of the system, such as the number of transactions it must process within a minute or orders it must take in an hour. Languages that the system should support. Is it a global system deployed worldwide, or will it be used in an area that has only one primary local language? This is also a good time to identify any regulatory requirements that the system must meet. For example, medical device companies often must keep a registry of devices and patients in which they're implanted. These registries are often regulated under federal law or regulations, and the systems must meet these. This is a good time to identify any such requirements. Other methods to gather requirements outside of interviews might include things like document analysis and ethnography. So we'll talk briefly about those two. Document analysis is just that. You often ask a user to give you an example of a particular document, such as, can I see an invoice? Or could I see an order? Analyzing the document will give you a good idea for the information requirements of the process. And document analysis often informs the other requirements gathering techniques. So you might use document analysis first, and that might help you prepare your interview questions or prepare for your ethnography. Document analysis provides a more objective look than a user. For example, you might interview 3 different users and get 3 different perspectives on the same process. However, document gives you often a very objective look at the data requirements for the process. Where possible, you should ask users for copies of important documents and put them in the file so that they can be used later to develop specific requirements. Finally, we'll talk about prototypes in more detail later in the course, but the final technique we'll talk about in this video is something called ethnography. Ethnography is essentially observing people doing their work. So if you're developing an order entry system, you might go observe someone taking orders and make notes. You, as part of this lesson, you've been assigned to watch a video that shows how a major research organization goes about conducting their ethnography. Gold plating is something we don't often associate with software. However, it has a very specific definition when it comes to systems. Gold plating is what happens when software developers often add features or functionality that they think would be interesting, but that the customer hasn't requested. Gold plating can be identified using a technique called traceability. We're going to use this video to talk about traceability and its importance in identifying problems and issues in the implementation of the software. Now, gold plating is a fun example where developers can often kind of get carried away implementing functionality, but traceability has a very real purpose in ensuring that the system that's eventually developed meets the requirements it was developed to satisfy. After this video, you'll be able to define traceability as it relates to our system requirements and describe at least one approach to documenting traceability. There are many, many ways to document traceability. And finally, we'll talk about 2 different types of traceability and why each is important. Just a reminder that we're in the analysis phase of the software systems development lifecycle, and right now our focus is on writing good requirements, which is one of the primary roles of the business analyst. Other videos will feature additional documentation and diagrams that the business analyst prepares in analysis phase, as well as talk about the role of the business analyst in future phases of the SDLC. Traceability is a technique that ties all project artifacts together. It is a required practice in many regulated industries. For example, an auditor might show up and you might make a claim about the battery in your medical device. The auditor might then ask, how do I know that this battery meets this specification? Oftentimes then, the people hosting the audit would then go to a traceability matrix to find out when and where the battery was tested to make sure it met that particular spec. Many enterprise case tools, which is short for computer-aided software engineering tools, support traceability in some form. So in other words, if you purchased or your organization has purchased a requirements management tool or a user story database manager if you implement Agile, many times they implement traceability, sometimes through a simple field that tells where that particular requirement or user story came from. There are a variety of other methods to handle traceability, and we'll look at a few examples. Here's one example that shows a pretty sophisticated traceability matrix. On the left, you have the source of the requirement, and then moving across the matrix here, we see that that requirement was exploded into two different product requirements. Those product requirements appeared in various documents that you see across the top, all the way down to the code unit, which is the precise file that implements that particular requirement, test case numbers, which we'll talk about in future videos, and then finally, how that particular requirement would show up in the user manual. This is a particularly detailed look at traceability that you might use in a regulated industry, for example, avionics or medical devices. Here's another example of how complicated these traceability matrices can get. Now, this is kind of an eye chart, I understand, and the purpose is not to understand the details here, but just to show that these things can get quite complex if you need them to be. On the other hand, we can often handle traceability in a much simpler way. This is an example that might use a traditional document tool such as Microsoft Word to manage requirements. And you can see that in the fourth column over here, we have an interview is the source of a particular requirement. So there are many, many methods to handle traceability. Traceability is important throughout the system's development lifecycle, not just from source of requirements to the requirements document, but beyond the requirements document into test cases, the user manual, and the eventual implementation of the software. It's also important once we get to the end of the system's development lifecycle that we have a way to kind of trace the end product back into its constituent components. Because of this, we have, or at least we refer to, two different types of traceability. Forward traceability moves forward through the system's development lifecycle, starting with the source of the requirement, making sure that it appears in the requirements documents, and then further making sure that it appears in test cases, that it's finally tested, and in the released product. Backward traceability starts at the end of the system's development lifecycle and moves backwards. It starts with an end product and then moves backwards to make sure that we can find evidence of those features in the test cases, that the test cases are tied to requirements, and that the requirements actually came from a business user. My question for you is, which one of these types of traceability identifies the gold plating that I referred to at the beginning of this video? This pretty much wraps up our detailed look at requirements. Future videos will talk about other aspects of the analysis phase and the business analyst's role in those artifacts.